My name is Inyoung Hwang, and I'll be going over the answers and explanations to the November of 2018 midterm exam for the PS30 class. This question has 5 sections, A to E, and I'll be going through each and every one of them. So let's first look at the problem. Problem 1 says Pete and Ariana have been dating for a month. Each person decides simultaneously whether to propose marriage or not. If they both propose, then they get engaged and each get a payoff of 10. If only one person proposes, the person who proposes gets -6, and the person who does not gets 6. If no one proposes marriage, they continue to date and both get 0. Model this, and Section A wants us to model this as a strategic form game and find all pure strategy and mixed strategy Nash equilibria. Now this is easy. First, we find the players of the strategic form game, and there are 2 players, which is Pete and Ariana, and they each have 2 choices: to both propose or not to propose. Now, based on this, we can make a 2x2 strategic form game. So first, let's put Pete as player 1 and Ariana as player 2, and make a simple table, a simple 2x2 table. And you can move this table to somewhere more appropriate. Now, the choices are to propose and not to propose for both people, or for both players. Propose, not to propose. And for the payoff, let's look at the question again. It says if they both propose, they get engaged and both get a payoff of 10. So we can add that in the box where they both propose, they both get a payoff of 10. And on the next sentence, it says if only one person proposes, the person who proposes gets -6, and the person who does not gets 6. So the scenarios where only one person proposes is these boxes. First, let's do the box above. Here, Pete is the one proposing, and Ariana is the one that's not proposing. So Pete will get a payoff of -6, and Ariana will get a payoff of 6. For this box, it is the opposite. Ariana is the one that's proposing, and Pete is the one that's not proposing. So Pete will get a payoff of 6, and Ariana will get a payoff of -6. And for the last box, it says, if no one proposes marriage, they continue to date and both get 0. So you can put 0 and 0. Now we have to find the pure strategy and mixed strategy Nash equilibria. For the pure strategy Nash equilibria, we can use the underline method. We look at the payoffs of Pete when Ariana proposes and compare the payoffs and underline the highest payoff. For this instance, where Ariana proposes, Pete proposing will have a payoff of 10, and Pete not proposing will have a payoff of 6. So because 10 is greater than 6, we'll underline 10. When Ariana is not proposing, 0 is greater than -6, so we can underline 0. Now for Ariana, because 10 is greater than 6, we can underline 10, and because 0 is greater than -6, we can underline 0. Here we have 2 pure strategy Nash equilibria. To propose, or to not propose and not propose. Now, for the mixed strategy Nash equilibria, this requires some more steps. First, we need to assign the probabilities that each choice will happen for each person. So for Pete, let's put P as a variable of the proposal that Pete will choose propose. And because there are only 2 choices for Pete and probability will always add up to 1, we can say that the probability of not proposing for Pete is 1 minus P. Same for Ariana, but instead of P, let's use Q so we can make the distinction. So Q and 1 minus Q. To find the to find the mixed strategy Nash equilibria, one has to use the indifference principle. To do that, we need to find the expected payoff of each person, let's say Pete, of proposing, and set it equal to the expected payoff of Pete not proposing. Let's look at the expected payoff of Pete when he is proposing. This is equal to the probability of probability Q going to 10 and negative 6. So it's 10 times Q and negative 6 times 1 plus Q, and you add them together to find the expected payoff. So let's do that. 10Q plus negative 6 times 1 minus Q. For when he is not proposing, then it is Q times 6 and 1 minus Q times 0. So that is Q, or 6Q plus 0 times 1 minus Q, which is just 6Q. And for the above, it is negative 6 plus 16Q. We can set them equal to each other. Negative 6 plus 16Q equals 6Q, which will give us 10Q equals 6, and that gives us Q equals 3 over 5. We can do the same thing for Ariana. The expected payoff for Ariana, or Ari to shorten, of proposing should be equal to the expected payoff of Ari not proposing. The expected payoff or utility for Ari to propose would be P times P times 10 and P and 1 minus P times negative 6. So that's 10P plus negative 6 times 1 minus P, which is equal to negative 6 plus 16P. For the expected payoff of Ariana, when she is not proposing, then it's P times 6 and 1 minus P times 0. So it's 6P plus 0 times 1 minus P, which gives us just 6P. And we can do the same thing. So negative 6 plus 16P equals 6P. That gives us 10P equals 6, and P equals 3 over 5. Whew, that was long. Now we can just write this into the mixed strategy Nash equilibrium. So the mixed strategy Nash equilibrium will be Pete will propose with a probability of 3 over 5, and he will not propose with a probability of, because he does not propose with a probability of 1 minus P, it will be 2 over 5. Say for Ariana, she will propose with a probability of, she'll propose a probability of Q, which is 3 over 5, and she will not with a probability of 1 minus q, which is 2 over 5. Let me rewrite this. And that's section A done. Now let's move on to section B. Section B says, Pete and Ariana gets engaged, but soon afterwards, Ariana is convinced by her publicist to break off the engagement. Now Ariana must decide on whether to propose marriage again and thereby stay in a relationship with Pete or not. If Ariana proposes, Pete chooses to either accept or reject his proposal. If Pete accepts the proposal, the relationship survives, and Pete rejects it. If Pete accepts the proposal, the relationship survives, and if Pete rejects it, the relationship ends. If Ariana does not propose, Pete chooses whether to stay single or start dating someone else. Ariana will get 15 if she proposes again and Pete accepts it. Ariana gets -10 if she proposes again and Pete rejects it. If Ariana does not propose again and Pete stays single, Ariana gets 0. However, if Ariana does not propose again and Pete starts dating someone else, Ariana gets -16 because he was the first to move on. Pete gets 12 if he rejects Ariana's new proposal because he gets payback for Ariana breaking off the first engagement, and Pete gets 7 if he accepts a new proposal because he loses the chance to get payback. If Ariana does not propose again and Pete stays single, he gets a payoff of 10, and if Pete starts dating someone else, he gets 8. Now, section B wants us to model this as an extensive form game and find the sub-game perfect Nash equilibria. or Nash equilibrium. First, let's look at the players. The players are the same as section A. It is Pete and Ariana. And the choices for is a bit different. Ariana has a choice to propose again or not. But Pete's choice is if Ariana proposes, he can accept or reject, and if she does not, he has a choice of staying single or date someone else. Now, let's start off with Ariana, as she has the first move. Ariana. And let's make the lines. Sorry. Yes. Now Ariana's choice is to propose or not propose. And let's make a new color. And if Ariana proposes, Pete can either accept the proposal or reject the proposal. Let's put Pete. But if Ariana does not propose, Pete can either stay single or date someone else. Now let's look at the payoff. It says Ariana gets 15 if she proposes again and Pete accepts it. Okay, so if Ariana proposes and Pete accepts it, Ariana will get a payoff of 15. If Ariana gets -10 and if she proposes again and Pete rejects it, okay, Ariana gets a payoff of -10 if she proposes and he rejects. If Ariana does not propose again and Pete stays single, Ariana gets 0. So she gets a payoff of 0 if he stays single. However, if Ariana does not propose again and Pete starts dating someone else, Ariana gets -16. So she will get -16 if he starts dating someone else. Now for Pete. Pete gets 12 if he rejects Ariana's new proposal. So Pete gets 12 if he rejects it. But he gets 7 if he accepts a new proposal. So he gets 7 if he accepts. Oops. And if Ariana does not propose again and Pete stays single, he gets 10. If he stays single, he gets 10. And if Pete starts dating someone else, he gets 8. If he starts dating someone else, he gets 8. So, this is the extensive form game. Now we just need to find the Nash equilibrium, subgame perfect Nash equilibrium. To do this, we can just use the technique known as backward induction. Backward induction, instead of looking in the normal way of looking at an extensive form game, we look at it from the back. Going back, looking at what the players will choose based on their payoffs. So for Pete, who chooses last, so it will be moving backwards. Pete can either accept and get a payoff of 7 or reject and get a payoff of 12. Now, because 12 is greater than 7, he will most likely reject the proposal. So we can just expect him to choose reject. Now, if Ariana does not propose, Pete gets a choice of staying single and get a payoff of 10, or date, or he can date and get a payoff of 8. Because 10 is greater than 8, he will most likely choose to stay single. Now it's Ariana's turn. We've already established that if Pete gets the choice, he will either choose reject and get a payoff of 12, or stay single and get a payoff of 10. Now, for Ariana, we need to compare the payoffs of -10 and 0. And because 0 is greater than -10, we can know that Ariana will most likely choose not to propose. This is the subgame perfect Nash equilibrium. To write this, we can say that the subgame perfect Nash equilibrium is to not propose for Ariana, and if she proposes, he rejects. Rejects. And if she does not propose, he stays single. Section C wants us to write this extensive form game as a strategic form game and find all pure strategy Nash equilibria of this game. Now, we just use the same method that we use to find the subgame perfect, the strategic form game in section A, but because we are transcribing the extensive form game to a strategic form game, there will be some differences. So, firstly, let's make the strategic form game. So it's Ariana as person 1, because in this extensive form game, Ariana is player 1 and she starts first, and Pete is player 2. Okay, now Ariana has 2 choices: to propose and not to propose. But for Pete, he has combinations of choices. So Pete, if Ariana proposes, he can accept. And if she does not, he can stay single. However, if Ariana proposes, he can also accept, but date instead of staying single if Ariana does not propose. Also, if Ariana proposes, he can reject and stay single if she does not, and he can also reject the proposal but date someone else if she does not. Now the payoffs we can derive from the first extensive form game. So if Ariana proposes and Pete accepts, they get a payoff of 15 and 7. However, if Ariana does not propose and Pete stays single, they get a payoff of 0, 10. We can just fill out the rest of the boxes in this manner. If Ariana proposes and Pete accepts, they get a payoff of 15, 7. If Ariana does not propose and Pete starts dating, he gets a payoff of -16, 8. If Ariana proposes and Pete rejects, they get a payoff of -10, 12. And if Ariana does not propose and Pete stays single, they will get a payoff of 0, 10. If Ariana proposes and Pete rejects, they'll get a payoff of -10 and 12. And if Pete starts dating when Ariana does not propose, they get a payoff of -16, 8. Now, let's use the underlying method to find the pure strategy Nash equilibria. So, because 15 is greater than 0, we can underline 15. Since 15 is greater than -16, we can underline 15. Because 0 is greater than -10, we can underline 0. And because -10 is greater than -16, we can underline -10. The same thing for player 2. So because 12 is greater than 7, we can underline both. And because 10 is greater than 8, we can underline 10. Here we can find that there are 2 pure strategy Nash equilibria. So pure strategy Nash equilibria, they are Ariana propose, but Pete rejects, and if she were not to propose, he would date. And also, she does not propose, but if she proposes, he chooses reject. But if she does not propose, he stays single. That is section C done. Now, for section D. Say Nikki, who is Ariana's enemy, conspires to embarrass Ariana. Nikki changes the payoff in the game in part B above. Nikki tries to motivate Ariana to propose again to Pete by offering benefits X to Ariana. When Ariana proposes again and Pete rejects it, Ariana's payoff is -10 plus X. Nikki also promises benefits Y to Pete if he starts dating someone else. If Pete starts dating someone else, he gets a payoff of 8 plus Y. All of the payoffs are the same as in part B above. Model this as an extensive form game. So because section D basically bases its answer on the answers of section B, we can just go to section B and copy the extensive form game so we don't have to write the whole thing again, and paste it here. Now let's just remove the stuff that we don't need. Okay, now we have a clean extensive form game. Oh, sorry. Now, however, there are some changes to the payoffs. So the changes are, when Ariana proposes again and Pete rejects it, Ariana's payoff is -10 plus X. So let's choose yellow. So if Ariana proposes again and Pete rejects, Ariana's, let's make it something more visible. Ariana's payoff is negative 10 plus x. So it's instead of negative 10, it's negative 10 plus x. But for Ariana, if Ariana, and the next sentence is also says, if Pete starts dating someone else, he gets a payoff of 8 plus 12. Let's change Pete's payoff for when Ariana does not, for when Ariana does not propose and he starts dating, his payoff will be 8 plus y. Now this is our new extensive form game. Now let's move on to section E. It says, the subgame perfect Nash equilibrium of this game depends on x and y, which is true. Circle all combinations of x and y below, which ensures that in the resulting subgame perfect Nash equilibrium, Ariana proposes again, and Pete rejects it. For example, if when x equals 4 and y equals 1, Ariana proposes again and Pete rejects it, circle x equals 4, y equals 1 below. Please explain your work. So, let's first try our best to go as far into the subgame perfect Nash equilibria as possible. We know that for Pete here, because these are unchanged, we know that Pete will choose reject over accept because 12 is greater than 7. However, for this branch, because there is a variable here, we cannot decide right now. So, the answer to section E, there are two different scenarios. Namely, one scenario is that so the two scenarios are 8 plus y should be greater than 10, or if 8 plus y is less than 10 for some reason, negative 10 plus x should be greater than 0. Yes. So the reason behind this is that for scenario 1, if x plus y is greater than 10, then it is most likely that Pete will choose date, as it is greater than 10. And if that happens because negative 10 plus x is always greater than negative 16, Ariana will most likely choose propose, giving us the desired subgame perfect Nash equilibria. However, if this does not happen and x plus y is less than 10, then that means that Ariana will most likely choose, Pete will most likely choose to be single, and for Ariana to still propose instead of not, her payoff negative 10 plus x should be greater than 0, giving us this scenario. So first, let's go through the first scenario. So this is simple algebra. So x plus y is greater than 10. That means that y should be greater than 2. And for scenario 2, if y is greater than 2, then negative 10 plus x should be greater than 0, and x then should be greater than 10. So, from these combinations shown, we can see that these combinations all have y greater than 2. So this is 3, 5, and 7. This means that all these combinations will give us the the subgame perfect Nash equilibria we want. However, in the section where y is less than 2, x should be greater than 10, and these two combinations have x greater than 10, which means that these combinations also give us the desired subgame perfect Nash equilibria. Therefore, the answer to this question would be circling all these combinations that we have found in our scenarios. And that is it. Yep. Thank you for watching.